Ciao guys, welcome back. Okay, can you please start sending me your sketches or your photos or the ideas that you have? So I can check what you were doing. Hi Camilla. Send me your works, please. Okay guys, does anyone have a sketches ready? Because if you do not, then I will then I will speak about some materials. Huh? Okay, last call for the sketches. If no one is there, then I'm going on, I'm moving on. Okay, so it seems that you don't have any questions. Let me show you this very, very cool material. So since 2 weeks ago, okay, Sophia, Laila, by the time you're uploading, just let me show you this one. So since last time we are speaking about the ceramics, and I have been telling always that ceramic is something very brittle and it's not ductile, etc., etc. But the ceramics can be actually flexible. And this is quite an impressive thing, because one can make actually the spring out of ceramics. Okay, so what happens when you want to cut a piece of glass? First of all, you scratch it, you apply pressure, and then you break it into two halves. Okay, how come it works? The reason is that you're introducing a flow, okay, a cut, into the surface, which opens up when you apply tension. This is the same principle that actually explains why ceramics are not very good under the tension, because ceramics are like glass. Okay, ceramics can like other materials, and for example thick plastics, it can have the same effect. So when I make a scratch and I bend the plate, it can break. Okay, so but as with the other materials, our behavior of ceramics can change through the process that's called transformation. Okay, that we tap the ceramic material and we can make it actually flexible. Okay, now the disadvantage of ceramics is that it has the pores or gaps inside the material. It's the material that is that has air inside. Okay, and the reason that those materials, for example, are tough is because of their ability to plastically deform. The nature of bonding of the items in ceramics make them hard and strong, but it also stops them from plastically deforming. This is the problem. By reducing the flow size in any material, you can increase the strength, so you can make it stronger. And these springs here that you can see provide a unique flexibility combined with a very, very high temperature resisting, because as you know, ceramics does not conduct the heat. Okay, And this would not be possible with metals, for example. Okay? So we can actually do springs out of ceramics, which is very impressive, because I don't think that many people can think of making a ceramic spring, but it is possible. So ceramics can be flexible. Impressive, eh? Like, these are some ceramic springs. Okay. So if I need the execution under a high temperature, okay, because metal obviously has some certain properties, that has the melting point that cannot be exceeded, okay, then what we can do is we can adapt the ceramics. Okay, Cosima. Okay, I will look at it. Mm-hmm. Hashit says to incorporate origami with mobile structures. Yes, perfect. Ok, bene. Allora, Cosima, like I've opened your issue already, so I can check. Solar system. Cosima is because of your surname. You decided to adapt this concept. Okay, sun. Mm-hmm. Okay. The idea is good. Is that be sure that it moves. So most probably you will have to use some threads here. So alright, keep in mind that like I showed you the video of Calder. You've seen how the movement was. So if I have something this big, okay, the movement is very, very soft. Okay, so it's not like an earring, it's not something like this, look, where I move it and it does this dangle, let's say. It's not that. So it has to have some kind of movement. So all U's have to be quite big. So it will make the movement, and in between there will be a bigger gap on the threads. Okay, so the movement has to be seen. Okay, so it can be a small movement, but it has to be continuous. Okay, like in the video that I showed you. Okay. And let's see. There would be movement caused by wind. Okay. The important thing that it moves, that it does not dangle, but it actually moves. So maybe in your case, it will create it will have almost 360-degree movement. Then it's fine. Okay, Jessica. Cosima, do you have any other questions? Okay, perfect. Okay, Cosima, Jessica, sorry, I'm looking at yours. Cool, this one. This one is very cool. I have no idea how you're gonna do it in terms of physics, so it has to stand somehow. But if you manage to do it, this is similar to what Calder did. Have you seen in the first in the very first part of the movie that I showed you, there was this like a silhouette of the person. So this can be a cool idea. So this has to be a continuous wire, but somehow it will have to move. Somehow. Maybe if you hang it, it would be, because then you would avoid making the base very strong. Mm. Mm. And those are rotating, eh? So he was creating a 3D portrait. Now yours looks more like Picasso painting, but still it's a bit similar, I think. The idea is very nice. Uh, this one is okay, but I think that this, if you continue, if you work on this one, adding maybe some more elements or creating more creating more I don't know, philosophy or something in it, maybe this would work. This one, it can work, but do it slightly more different from the one of Calder, okay? Allora, Laila. Laila, I'm looking at yours. Time travel device. Wire. Laila, can you please explain how this is going to work? So I understand how it is, but I don't see the movement. The bobby pins are amazing, eh? This is really cool as the material. Okay, Sophia, we'll look at yours after Lila. Ah, okay, so you still have to brainstorm. Okay, the important thing that it moves. Okay, so it has to be movable. So with, as I said, with breath, like if I blow in it, with wind or with touch, it has to move. Okay, um, try to not to make it that symmetrical as well, huh? Because symmetry is not nice. Actually, what Calder did uh, was so all his sculptures were extremely asymmetrical. Mm-hmm. Okay, the middle part is the same. Well, this I understood, is that it has to be. And you push the top bar handle like a motor. Well, imagine that to make it rotate like a motor, you will have to have ball bearings. Because if not, it's not going to move. The movement has to be very, very smooth. Eh? So I think in your case, maybe instead of making a wire cage, maybe it could be a nice idea to make it hang. You know, to put it on the ceiling, let's say, somewhere, and then to make it as a hanging structure. I'm still continuing doing my mobile as well, huh? Okay. The bobby pins are really cool as the idea. Okay. And then we had Sophia. Mm-hmm. Together, alone. Wow, that's a very contradictory name, huh? In every circle, there is a different scenario out of daily life made with wire. Light projects them to the wall, and the idea is everyone behind connected and yet still alone on the same time. A very it's a very common concept these days, especially when individual fates and lives. Cool. The idea sounds very, very good. Okay, very nice. Be sure that the joints here are moving, and don't make it exactly like Calder. Okay, so maybe the shape can be slightly different, so it will not be considered as plagiarism. Okay, but the idea is very nice, and I think the concept is very strong. Obviously with light here one has to be careful, because the shadows are not going to be very how do you say, very sharp. This may be the problem. But for the rest it looks very, very cool. Okay. Okay, very nice. The concept is very cool. Allora, Brittany. Okay. Um, nice. The shapes are beautiful. I don't like the base. I think the base is a little bit killing it. So, or the base has to be lighter visually, not physically, but visually. Or why don't you turn it? Why don't you just turn it upside down? What if you do something like this? No, I can't turn it here. Ruota. Look. Imagine that this would be the ceiling. Okay, so this part here so this part here is completely absent. Okay. And these guys are actually hanging on something, very thin. I think this would be very cool because they look upside down. You're this is this is the hanging part, and then your piece is actually up like this. So instead of going down, it would look up. I think this is very cool. Okay. Limb. Okay. If you use this these shapes, it can be really great because it will look like wings. I think if you do something like that, like imagine some kind of a structure. So obviously I'm not saying to do exactly this, but some kind of a structure where you would have those fans, because this is beautiful, eh? Okay, well, I'm not saying to do exactly this, but something in this direction. So this will look beautiful. Maybe you can use different paper. So here, what you did, here what you did is you used only one type of paper. Okay, so maybe you can use, I don't know, one can be the napkin, one can be the white paper, one can be the sketch paper, the tracing paper, for example. This could be cool. Okay. Okay, guys. So next week, please bring your sorry, show your works. Okay. Um, make make your mobiles. Experiment. Think what can be a nice material to work with. By the time I was chatting to you, I did my stick really long and it's really rigid. Okay. As I said before, whatever materials you can find, it can be even toilet paper, it can be cotton, it can be anything that you have at home. Okay, because now I think everyone is in quarantine, no one can go out, so please do not go out, do not stay safe, and work from home. Okay, so by no means I'm asking you to do something illegal. Make the creations, okay? Create interesting things with aluminum foil, with cardboards, with whatever material of a fabric. I don't know, if you find fabric, for example, this can be an interesting thing. Toilet paper is rare. Well, yeah, that's true. Anything, okay? For materials, you are completely free. Okay? So, I wish you a nice weekend, guys, and I'll see you next week. Okay? Ciao, ciao. Thank you, Cosima.